Okay, your homework questions. 7a. So it gives you two vectors and it wants two forces and it wants you to find the equilibrating force. It wants you to find F3. So F1 is going east 22 degrees south. So that should be down here, right? Where this is 22 degrees. And this is 154 newtons. So this will be F1x and this will be F1y. F2 is going west 74 degrees north. So it'll be up here where this is 74 degrees. This will be F2x. This will be F2y. And this is the 203 newtons. So first steps are to find the x and y components. The x for F1x is the adjacent side, so it's cosine. So cos of 22 degrees will equal F1x over 154 newtons. So F1x will equal 154 newtons cos of 22. And when you do this on your calculator, you will get 142.79 newtons, and that will be east. If x is cos, y should be sine, so this one will be sine of 22 is equal to F1y over 154 newtons. So F1y will equal 154 newtons sine of 22. So F1y should equal 57.69 newtons, and that will be south. Okay? So then you go to your x2 and your y2. And I'm hoping at this point, oh, maybe I should do one. Okay, so x, cos again. And I'm okay, like, so it's going to be cos of 72 is equal to F2x over 203. So I'm okay if you want to just go right to F2x is equal to 203 newtons cos of 74. If you don't want to write this first part down, if you can do it to here. And I'm hoping that I didn't confuse you by going right to there. So this is F2x. And so F2x should be, I think, 55.95 newtons. And that will be west. And then if F2x is cos, F2y should be sine. So it should be F2y is equal to 203 newtons sine of 74. And when you do this one, F2y ends up being 195.14 newtons. And that would also be north. So then once you have these, you're going to add them together. You're going to do the total in the x direction. Whoops, that's supposed to be a sigma for sum of. In the x direction. And you're going to end up having to subtract these because one is east and one is west. And when you subtract them, you should get 86.83 newtons. East is bigger, so it ends up being east. So that's your total in the x. Your total in the y, they're both going north, so when you add them together, oh, I take that back. That one's south. Too bad I can't see. There, one's going south, one's going north. So again, you're going to subtract 137.45 newtons. And the north one is bigger, so it wins. Okay, so you now have something going east, 86.83 newtons, and something slightly larger going north, 137.45 newtons, and so you're going to find the resultant. And I'm going to scratch this piece out so that that one's really is larger. So square them, add them together, find the square root, find the theta, and you will get F net is equal to 162.58 newtons. And when you do the angle, It's 57.72 degrees. Off which way? East. Going which way? North. That's the F net, but it wants what must F3 be to be the equilibrium force. It must be 162.58 newtons west, 57.72 degrees south. And that is your final answer. Okay, that's A. Now we go to B. Okay, so again, we're going to draw it. Whoops. So F1 is east and north, 12 degrees, so it's here. This is 12 degrees. This is 782 newtons. This will be F1x. This will be F1y. And then F2 west south, it'll be down this way. So this will be 629 newtons. This is 29 degrees. This will be F2x. This will be F2y. And again, you're going to do sine and cos. So F1x is going to be cosine. So F1x should be equal to 782 newtons cos of 12. So F1x should be equal to 764.91 newtons, and that'll be east. F1y should be 782 newtons sine of 12. So F1y should be equal to 162.59 newtons, and that will be north. Then do your F2s. X again is cosine, so F2x should be 629 newtons cosine of 29, and you should get an F2x of 574.62 newtons. That is going west. F2y, 629 newtons sine. Oops, forgot my newtons. Sine of 29. So F2y should be 255.84 newtons, and that one should be south. Okay, so you have your total, your 2 and your x, your 2 and your y. You're going to add them together. You get the total in the x to be 190.29 because you're adding them but really subtracting. And the east is bigger. Total in the y. Again, opposite direction, so you're subtracting. 93.25 newtons south is bigger, so this will be south. So when you draw it, you have east 190.29 newtons, south 93.25 newtons, and here is your F net. And here is your theta. So square them, add them together, find the square root, and you will get 211.91 newtons. The angle is going to be 26.11 degrees. It's going east and then south. So your F3, your equilibrium, 211.91 newtons, and instead of east it'll be west, still 26.11 degrees. Instead of south it'll be north. Hopefully these are getting easier. We're going to run out of time on this one, but let me at least get it drawn. Okay, so if we draw these three, the first one is west-north, so it's up here. This angle is 81 degrees, and this is 48 newtons. Next one is east-north. It's up here. 61 newtons and 63 degrees. And the third one is east-south. It's down here. Whoops, the angle's too big. 15 degrees and 78 newtons. So